All right, welcome to task 25, Intro to Decimals. So when we talk about decimals, we're really talking about, kind of the flip side or the opposite side of whole numbers. And, a lot of this is going to feel similar, but it's going to be like in the realm of decimals. So, if you look, our first chapter was simply whole numbers. Our second chapter is all fractions. And now we're going to do decimals. So in all three chapters, what did we do? Well, we introed it. We added, we subtracted, we multiplied, we divided. We looked at the word problems that went along with it. We looked at the order of operations that went along with it. And that's pretty much it. There's one other thing we put in this chapter, square roots, at the end. But really, if you follow the same, guidelines as whole numbers for especially the first chunk of this, it's going to be kind of, you're going to feel like some of these words are similar. So if you look, when we did the place value chart for whole numbers, it was ones, tens, thousands, 10,000s, ones, tens, hundreds, thousands, 10,000s, 100,000s, and then million. All of them ended with, a D, an N, one ends with an E. So I hate to say they have a commonality in that they don't really have anything in common, but you kind of see, there's not a specific thing for the whole number piece to it. If you look here, though, at the decimals, you will notice that they all end with THS. So you're talking about the tenths, the hundredths, the thousandths, the 10,000ths, and the 100,000ths. Okay? We don't have a ones place for the decimal. We start with tenths, and you'll see why in a little bit. So if we want to place the number from number 1, we want to place 0.54. We're going to put the decimal here. We're going to put the 5 here, and we're going to put the 4 here. So it's 5 tenths and 4 hundredths in this problem. If we put the next one, point, and we can have the 0 in front of it in the ones. You can also drop that too. You can drop any zeros that are in the ones place. You can drop anything that comes after. You cannot drop any zeros that come before or in the middle. So we have 0.30716. And then this last one, 5.678. So again, in that middle one, in the green one, we have 3 tenths, no hundredths, 7 thousandths, 1 10,000ths, and 600 thousandths. In the third one, I picked this one example specifically because when we read this, it's 5 and 678 thousandths. When you read the problem as a whole, you're only going to read that last place. So, starting again from the top, we have 54 hundredths. Okay. The second one, the middle one in green, we have 30,716 hundred thousandths. So you want to read the number just as you see it, and then you want to add the label at the top. And then the one on the bottom in red, 5 and 678 thousandths. Because again, that's where your last digit occurs. It's the place value of your last digit. All right, so going on to number 2, in each number, identify the place that the digit 7 occupies. So if we underline the 7 in each of these, okay, this is the first spot, which is the tenths, THS. THS at the end. Okay. The number 3, it's the tenths, hundredths, thousandths, 10,000ths. And then number 4, we have that second digit, and that's going to be the hundredths. All right, so now express the following fraction in fractional form and simplify. So when you're reading that, you're really reading that as 35 hundredths, using that chart again. If you kind of build that chart in your head or list out those place values, this is really 35 hundredths, right? Now, considering they are hundredths, it would make sense that 100 is somehow involved. And if you kind of look back up top, you see that it's that 1 over 100, right? That's what would give you one of them. So if there's 35 of them, essentially 35 is your top number and 100 is your bottom number. The trick we're going to use for this is we want to make it fractional. So we want to turn it into a fraction. So we're going to have a top and a bottom. So on the top, you're just going to take whatever number is to the right of the decimal. So whatever number is to the right of the decimal. Now the number on the bottom is always going to be 1, and then however many zeros there were in the digit from above. So there's 2 here. I'm going to add 2 zeros there. Okay, so this ends up being number of zeros from number of digits above. Okay, and then we of course want to simplify because we always want to simplify. So if we have 35 over 100, they're both divisible by 5. 35 divided by 5 gives me 7. 100 divided by 5 gives me 20. So my answer is 7 over 20. Now it says for the next one, express the following as a mixed number. So we're going to do the same process, but we're actually, at the end, a mixed number would have a number here, right? So in number 5, it didn't have that. In number 6, it does. So we are going to do the exact same process. We are going to make a fraction. On the top, we want the number after the decimal. And on the bottom, we want a 1 with that many numbers, that many zeros behind it. So 63 is 2 digits long. We're going to add 2 zeros to the bottom, and we have 63 over 100. Now that doesn't simplify. In order for this to be a mixed number, though, and this makes sense if you look at the problem, this was 1.63 or 1 and 63 over 100. So this 1 gets brought down at the end as your whole number piece, and you're all done. Okay, so let's try number 7. We're going to do the same thing. We're going to make a fraction with what's after the decimal. So there's only one number after the decimal, that's a 4. So on the bottom, we're only going to put a 10, and this makes sense because it's 5.4 or 5 4/10. Okay, so 4 over 10 would make sense. And again, keeping that 5 involved, we want that to be our whole number piece to our mixed number. Now, for that one, you have to simplify, so we're actually not done. And these are both even, so you get 5 2/5. You don't change the whole number when you are simplifying, just the fractional piece. All right, let's see. Next page. All right, so we're still doing that. So now we're going to have these 3 digits after. 3, 2, 1. over 1,000, because remember, the number of digits on top matches the number of zeros below. And then I kind of wrote over it, but we're going to take the number from the left and we're going to use that as our whole number. And we would have to simplify this if we could, but 321 and 1,000, they do not have any common factors. So we're all done. And then for this last one, number 9, the 29 comes down and that goes over 100 because 2 digits on top, 2 zeros below. The 4 comes down as our whole number piece to our mixed number. So number 10, again, that chart might help you if you kind of think to where if that's the decimal, it's tenths, hundredths, thousandths, 10,000ths, 100,000ths, okay? Just like on the left side, working up more as you go to the left. So if we have 9/10ths, that means we're going to end here, right? So remember, you want to end in the place, however many over to the right, that your word is, right? So here we have 10,000s. So if we're ending at 10,000s, that means we want 1, 2, 3, 4 digits. So essentially we can create this template for ourselves. It's going to be a decimal and 4 digits. As soon as we see the word and, that means it's your decimal. So essentially that's almost like splitting the problem. So now with this 6, that's going to be your whole number piece. Okay. And if you have 47 10,000ths, we're putting our numbers in from right to left. So this is opposite of how we'd read. So if it's 47 10,000ths, we're going to have the 47 here, and anything else is a placeholder, which is a 0, which we need. We can't drop that 0. It's important because if, that number that we just wrote is different from that number, right? The number on the left says 6 and 47 10,000ths. The number on the right says 6 and 47 hundredths. And I know that because I'm only ending 2 places over to the right. So they're not the same thing, okay? You cannot just drop zeros out. So if we're comparing numbers, it's helpful to have the numbers vertically. Like a lot of time we talked about it being easier. And it's very important all through decimals, or mostly through decimals, especially starting here, that we line up our decimal, okay? So when we line it up, this is, again, it's kind of like that alphabetical order thing. We read from the left to the right and we keep going until we see a number that's different. Now, if we don't have any numbers, like we have this blank spot here, you can put a 0. So looking top to bottom, the 8s are the same. So the 8s being the same, that doesn't help us. But then this 1 and this 4 are different and the 1 is smaller. So that means that if I'm comparing these two, 0.813 is smaller than 0.84 or 0.840. Okay. Similarly, if we want to order these from least to greatest, the first step I'm going to do is write them. And again, this is the piece where it's really important. You line up by your decimal. You do not line up by how many numbers you have, because if you were to line this up like this and you're comparing those numbers, 1.1 is very different from 0.31. So 1.1 and 0.31, they're very different numbers, but if you're lining them up without any regard to the decimal, they're not going to look like that. So we don't want to do that. We want to line up to compare by the decimals. Okay, so we have that, and then we're looking for, which one is bigger or least to greatest or however you want to call it. remember that anywhere you have those blank spaces, you can kind of even them out with the zeros. So right away that helps you to see that if we're going from least to greatest, our least is definitely the one with the 0 as our whole number. So we have 0.31. And then if we compare, the ones, these are the same, these are the same. It really came down to these. So those are very, very close numbers in terms of how big they are. So 1.1 and 1.13. Notice how when I write my answers, I write them how they were given to me. I don't write them with any extra zeros. I don't write them with any placeholders. I don't change the form at all. If they give it to you as a decimal, you want to give it back to them as a decimal. The only thing we can really drop and not worry about is, again, that 0 out in front. We're allowed to drop that. All right, so looking at rounding these things, all right, we are actually thinking about, these you're going to have to put to memory. There's no ifs, ands, or buts about it. If they say that, you're rounding to the nearest tenth, that means you're going to have 1 decimal. If you are rounding to the nearest hundredth, you have 2 decimals. Thousandth is 3 decimals. And 10,000 is 4 decimals. Now remember, you're rounding 2, so at the end you want to end up with that many digits. Okay. Now, with that, again, what's a good way to remember? What's an easier way to remember? What's a trick to remember? When you're talking about tenth, you're talking about the number 10. It has 1 0. When you're talking about hundredth, you're talking about 100, and you're talking about 2 zeros. When you're rounding to the nearest thousandth, you're talking about a 1,000, and that has 3 zeros, and 10,000 obviously has 4. So really, if you know how many zeros are in the numbers 10, 100, 1,000, and 10,000, and you can come up with that, then you know where you're rounding it to. So if I'm rounding 46.271 to the nearest tenth, that means I'm rounding it to here. I want that decimal, so I underline the one I want to keep or end with. So I want to end with 1 decimal, which means I'm circling here, and I'm saying, what does that 7 do to the 2? All right, and that 7 makes that 2 a 3, and then remember, anything else comes after it. But usually rounding is for the fact we couldn't drop the zeros in whole numbers because zeros at the end matter, right? 1, 2, 3 is not the same as 1, 2, 3, comma, 0, 0, 0. If I have $123, that's a lot different than me having $123,000. But here, 46.300 is actually the same as 46.3. You are allowed to drop those. So your answer to the nearest tenth is 46.3. Now, if we're taking 46.271, again, we go back to the original, and we're rounding to 2 decimal places, that means we are keeping that, and we're looking at that. So I have 46.2, the 7 stays a 7, and then I drop that 1 back to a 0, because anything after that underline becomes 0. Anything after that underline can be dropped. So that is really 46.27 rounded. All right, looking at the nearest thousandth. Now, this means I want this one. Okay, that's where I want to end up. I want to end up with 3, so I'm actually looking at this right here. But if nothing's there, that really means there's a 0 there, right? So if I'm saying, what effect does 0 have on a 1? It has no effect, right? So it's 46.271, and I'm done. Sorry, my 1 got lost there. 46.271, and I'm done. All right. Now, you have to watch because they can throw something like this at you where they say, okay, we'll round to the nearest 10. And 10 has no TH at the end of it. So now we're rounding on the other side of the decimal. We're rounding to this because it's ones, tens. So if we're rounding to the 10th, to the tens, and I'm looking at that 6 to do it, the 6 makes the 4 become a 5. And again, anything after that number, after that underline becomes a 0. So I have the 0 and then the decimal and then 3 more decimals. Now, we just talked about this. I can drop these decimals. I cannot drop that one because 5 is different than 50. But 50 is not different than 50.00. I mean, if you think about money and different ways to write it, $50.00 is the same as $50. So this one is 50. All right, and then rounding to the nearest whole number. So whole number, that's really like saying ones place. Okay, and that means I am looking to round here. I can jump the decimal, which means I'm looking at that 2, which is on the other side of the decimal, and I'm saying, what does that 2 do to the 6? And the answer is it does nothing. It keeps it the same. But then anything after that underline becomes a 0, and we know that we can drop any zeros after the decimal. So 46 is my answer. If you put 46.00, you are not going to be marked wrong. All right, so if we look at this one, round to the nearest 10th, 10th is right here, which means we're looking at the 6. Now, what does the 6 do to the 9? Well, the 6 bumps the 9 up to a 10, which we can't have because we can't ever have a 10 in one place. So it actually bumps over to the 6 and turns the 6 to a 7. And then everything else is zeros after that. So rounding this one to the nearest 10th actually rounded it to the nearest whole number. And the last one, the price of the gallon of gas is, and this is a true story. You go to the gas station and they actually, you see like $2.45 and $2.45 and 9/10 of a cent. That's just how they've always done it. So the price of a gallon of gas is often expressed in terms of thousandths. Suppose that the price of gas is 3.769. What is the price to the nearest cent? Now, for anything money, we want 2 places after the decimal. Okay, so that's for any money. We're going to round to so that it's 2 places to the nearest hundredth. So if we have 3.679, we want that second place, and the 9 tells us what to do. So the 9 turns the 6 into a 7, and we get 3.77. And again, we have that 0, but we really don't want it. We want to drop it because we're talking about money. And money is always in that form, which is the whole number and then 2 decimal places after that. Okay? All right. Let me know if you need any help. Do the independent practice and move on to the next.